In this video, we will be solving nodal analysis for a circuit with a supernode. I have modified my steps from the previous video and added this highlighted section over here. The only difference is that we just treat the two nodes that are connected by a voltage source as one combined node, and the extra equation of the voltage source becomes the equation I wrote in the example. So starting off with this node, the first thing we want to do is label our nodes. So I want to say that this is V1 over here, that this is V1 over here, this is V2, and this is V3. One thing we can see is that there is a 12 volt combined with the V3 and the V1. So I'll be writing my equation as V3 minus V1 equals 12 volts. So if I want to write my V3 in terms of V1 to have one less equation, in a way, I will say that V3 equals V1 plus 12. And then we chose our reference node. I'm going to choose the bottom over here to be 0 volts, just by preference. I usually choose the negative terminal of what I'm finding to be 0, because then whenever you find the equation, you can just do V0 minus like V3, for example, minus 0, and it becomes much easier like that. But it's just my personal preference. It's something you have to do. So these are all 0 volts on the bottom. Starting off with our first equation for V1, I will say that V1 minus 0 volts over 2 is the current for the 2 kiloohm resistor. Next, going from V1 to V2 for the 1 kiloohm resistor, it will be plus V1 minus V2 over 1. But the only difference here is we cannot forget this node, and because it has a V1 value, we need to include that in our equation. So to continue this, we do plus V1 plus 12 minus 0 volts over 1 plus, the next one will be from V1 to V2, plus V1 plus 12 minus V2 over 2 kiloohms equals 0. Our next for our equation for V2, we have V2 minus V1 over 1, current going towards V2, minus 4, then from V2 to V1 plus 12, plus V2 minus V1 plus 12 over 2 equals 0. And now solving the equation, we get 3V1 plus negative 3 over 2 V2 equals negative 18. And for this one, we get negative 3 over 2 V1 plus 3 over 2 V2 equals 10. And for V1, we get negative 16 over 3. And for V2, we get 4 over 3. And then once again, to find V0, just going to be V0 equals V1 plus 12 minus 0. And with that, we get V0 equals 4 over 3 plus 12. 40 over 3, or 13.33 volts. Now for this circuit. First thing I want to do is choose my nodes. I'm going to choose this node V1. I will choose, this is my V2. I will choose this node up here as my V3. And I will choose this node over here as my V4. And this over here is my V5. Bottom nodes. I will say that looking at the 6 volts, positive minus negative, V3 minus V2 equals 6 volts. And looking over here, positive minus negative, I will say that V5 minus V4 equals 12. With this, I can get that V4 equals V5 minus 12. And with this over here, I can get that V2 equals V3 minus 6. So for this first equation, I'm going to start with V1, pretty easy. V1 minus V3 going this way over 2 is the current for the 2 kiloohms. I'm going to say that I'm going to do this one now, the current for there. V1 minus 0 volts over 2. And I can see that I have a current going towards V1. So I will say that's negative 4 milliamps, which equals 0. And now for the next node, I'm going to choose V3. It's going to be here, here. And don't forget, if there is a value, like a unknown, we have to include all unknowns in the equation. So this V3 minus 6 is also included. So I can see that there is 4 milliamps going away from V3 minus 6. So that's a positive 4 milliamps. The current from V3 minus 6 to 0 volts would be plus V3 minus 6 minus 0 over 1. And now focusing on just V3, including this equation, I will have V3 minus V1 over 2. And then we have a 2 milliamps going towards V3, so that's going to be a negative 2. And then lastly, we want this equation from V3 to V5 minus 12. So that's going to be V3 minus V5 minus 12 over 1 equals 0. And for the last node, V5, make sure to include everything that has a V5 in it, every node. So our equation 3, we have a 2 milliamps going away, so that's going to be negative 2. We have a V5 to ground plus V5 minus 0 volts over 1. And we have a V5 minus 12 to ground plus V5 minus 12 volts minus 0 over 1. And we have a V5 minus 12 to V3. So it's going to be V5 minus 12 minus V3 over 1 equals 0. So with this, we get V1 to be, the equation 1 to be positive V1 minus V3 over 2 plus 0 V5 equals 4. We get our equation 2 to simplify to get negative V1 over 2 plus 5 over 2V3 plus negative V5 equals negative 8. And we get 0 V1 minus V3 plus 3 V5 equals 22. And we get our V1 to be 4.3478. Our V2 to be 0.6957. And our V3 to be 7.5652. And since you're trying to solve for V naught, positive minus negative, V naught equals V5 minus 0 volts, or V naught equals 7.5652.